Today we're going to be writing equations of hyperbolas. Our objectives are to be able to write the equation of a hyperbola in standard form given specific information about the hyperbola, and to be able to write the equation of the hyperbola in standard form given the equation in general form. So just as a reminder, here are the standard forms of a hyperbola, whether it's a left-right hyperbola where the x comes first is positive, and a hyperbola that's up and down where the y comes first. So we're going to have to determine that. We're also going to have to know the center, our h and k, and then we're going to have to know how much we move horizontally, our a value, and how much we move vertically, our b value, of our rectangle to get our standard form. So in our first equation, I'm going to actually just use this little graph off to the side just to make it a little bit easier for you to see. But again, for my class, you're not going to be given a graph, you're just going to have to map it out, and I will go through some examples like that. So the first one, I have vertices at negative 8, 3, so negative 8, 3, and at positive 2, 3. And then I have two focal points at negative 10, 3, and at positive 4, 3. So I can tell a couple of things right now. One, I know that this is a left-right hyperbola, which tells me that in my standard equation, the x value is going to come first. So I know it's going to be an x quantity squared minus, remember we're dealing with hyperbola, so it's a subtraction, a y quantity squared. And this should always equal 1. Okay. I can also tell where the center is going to be, because the center is going to be the midpoint of the vertices or the midpoint of the two foci. So, again, if you want to find the midpoint, you can just add and divide by 2. So if I add negative 8 and 2, or you could count if you have a graph, but negative 8 plus 2 is negative 6, divided by 2 gives me a negative 3. And if I add the two y's, I get 6 divided by 2, which is also 3. So at negative 3, positive 3, and you can always count to make sure you're right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so now that I know my center, I know it's a negative 3 for the x, which means it's going to be plus 3 in my equation, and a positive 3 for the y, which means it's going to be a negative 3 in my equation. So, unfortunately, they didn't give me enough information to draw my box immediately, but I do know how much I move to the right and to the left, and I can count, which is 5. So that's my a value, or the value underneath my x, so if it's 5, 5 squared is 25. So just from this, I'm able to get almost the entire equation written in. The only thing I don't have is how much I move up and down, my b value. Well, remember what we did for an ellipse. A squared we know is 25. B squared, my up and down movement, I don't know. And I know my c squared, because I know if I count how many spaces I move from my center to each focal point, is 7. So if I move 7 left and 7 right, c squared is 49. Well, remember for a hyperbola, we know we have a formula a squared plus b squared equals c squared. So 25 plus what will give me 49? Well, we could just do a little bit of an algebra. We could do 49 minus 25, and we're going to get 24. So I know underneath my y squared is 24. Now that's not a perfect square, and there's nothing wrong with that. It just makes it a little bit harder if I had to graph this. But we're not graphing this. We're actually, our main goal is just to write the equation. So I have 25 and 24 as my denominators. Okay, so here's an example where I don't have a graph. So how would we do this? Well, I have vertices at 7, 2, and 7, negative 2. So if I notice, my y value is changing. So I know that's going to be the up and down. So what I'm actually going to do is, because I don't know where everything is, I'm just going to actually draw my rectangle. And I know that up and down, I have a 7, 2, and down at the bottom, I have a 7, negative 2. Okay, and because those are my vertices, I know this is an up-down hyperbola. And since I have an up-down hyperbola, I know the y value is going to be first. So it's going to be y quantity squared minus my x quantity squared. And again, equal to 1. So just like I did before, okay, I'm going to find the center. Now, again, we do have my two focal points at 7, negative 6 and 7, positive 6. And we can draw those in. So, but again, it doesn't matter if I use the two focal points or the two vertices to find my center. And I'm going to take the average. 7 and 7 is 14. 14 divided by 2 is 7. 2 and negative 2 added together is 0. Half of 0 is 0. So I have a center at 7, 0. Now this we have to be careful. The 7 is with the x, so I'm going to write negative 7 here with the x. Now I have a 0 with the y. And typically when we do that, I have a 0 there, but what we would really write for my final answer is y squared. Okay, x minus 7, quantity squared equals 1. Okay. Because writing the 0 is kind of redundant, we don't ever usually do that. So this is what it would look like in a cleaned up form. But if you need to do this first to help you, go right ahead. So how much did we move up and down? Well, if I'm at 7, 0 and I go to 7, 2, I move 2. And to 7, negative 2, I move 2. And I like to check both of them just to make sure I didn't make a mistake with my center. So if my b value is 2, b squared is 4. And again, b goes underneath my y because this is up and down movement. But again, I don't know how much I move left or right, and that's where my a squared plus b squared equals c squared is going to come into play. I know the b squared is 4, and now c, how much did I move from my center to each focal point? Well, if I count here from 7, 0 to 7, 6, I move 6. And again, the same thing here is 6. You don't have to draw both of them in, but it's nice to double check, which means c squared is 36. So what plus 4 is 36? And the answer is 32. And then that would be my final answer in standard form. So in our third example, I give you some different information. I give you the transverse axis at x equals -4, and I give you the equation of the two asymptotes in point slope form. Now this can seem a little bit harder, but remember the asymptotes being in point slope form is really helpful because I'm telling you where the center is, because that's the point that both asymptotes go through. So my center is going to be at -4, 2. And because I told you I have a vertical line for my transverse axis, because x equals -4 is a vertical line, I know this is an up-down hyperbola, because the transverse axis connects the two vertices. So I can start to write this since I know it's going to be a y minus 2 quantity squared minus x plus 4 quantity squared equals to 1. Alright, so but I didn't give you any vertices, I didn't give you anything like that. But remember the slope. And if I have a rectangle in here, and I know I have these asymptotes that go through the diagonals, remember slope is rise over run. So I know that I went up 4 and over 3. Now I didn't give you enough information to know if that slope had been reduced. So if I don't give you any more information, we're going to assume that I went up exactly 4 and over exactly 3. Because technically I could have went up 8 and over 6. But in these more basic problems, if this is all I give you, we can assume that the b value is 4. So my b value equals 4, the up and down movement. And then the a value is 3, my left and right movement. So that means a squared is 9, and that goes under my x. And b squared is 16, which goes underneath the y. So let's look at one more of those. Here, I'm giving you the clue that my transverse axis is horizontal, which means that this is a left-right hyperbola, which tells me that the x value is going to be first. I'm also telling you what the center is by my point slope form. Now this doesn't look like point slope form, but it is because it's y minus 0 equals plus or minus 2/5 x minus 0, because those two are equivalent. So my center is at 0, 0. Given that, and it goes left and right, my x value comes first, so I can just write x squared minus y squared equal to 1. And now, because I know my slope is 2/5, I know my rise is 2, and the run is 5. So this is where the rectangle would be. Which means the a value is 5, and the b value is 2. So underneath my x should be 25, and underneath my y should be 4. Now in the chapter review you will see some more difficult problems like this where I give you some different information, but for our homework and what we're doing at the very beginning, this is the kind of problems you're going to see. Next we're going to look at problems when you want to go from general form to standard form. This deals with completing the square. We've already done these with parabolas and circles and ellipses, and now we're dealing with hyperbolas. Hyperbolas put a little twist in it because of that negative sign. It can mess some students up, so I'm going to try to highlight that for you when going through these examples so you don't make that mistake later. Just like an ellipse and a circle, we have x squareds and y squared, so we're going to keep those two variables on the left hand side. The only thing I'm going to do is put them together, so I'm going to group them. So I notice with my x squared and my x squared is a 1x squared, and we can complete the square only when we have a positive 1 as a lead coefficient. So I'm going to go right away and put my plus blank. But when I get to the 25, I notice I have a negative 25 in front of my y squared. I need a positive 1, so I'm going to take out a negative 25, and this factoring of a negative 25 is where many students make a mistake. So equals, well, what it gives me inside once I factor out the negative 25 is a y squared. And if I factor out a negative 25 from a positive 100, I get a negative 4y. And again, whenever you do any sort of factoring, it's always best to distribute again to see if you get back to my negative 25y squared, and now I get my positive 100. Now I can put the plus blank equals. And the other mistake that happens all the time, and I'm not quite sure why, is students refuse to, when they move the negative 76 over, to actually add 76 to both sides. So make sure that's a positive, and then I'm going to do my plus blank to represent those two plus blanks. Now I'm just going to complete the square. Half of negative 14 is negative 7. When I complete the square, I'm going to put 49 on the line, minus, I have to keep this 25 here, it doesn't go anywhere. Y, half of negative 4 is negative 2. Quantity squared is 4. Now, just like we had with some of the ellipse, remember there's an imaginary 1 here. 1 times 49 is still 49. But here, negative 25 times positive 4 is negative 100. Well, if I subtract 100, I have to subtract 100 from the right side. So equals, and now I want to add all this together. Again, if you don't have a calculator, just go left to right. 125 minus 100 is 25. But remember, we're dealing with a hyperbola. It has to equal 1. So I have to divide every term, or think about dividing both sides, by 25. So my final answer would be x minus 7 quantity squared divided by 25, minus the 25s would reduce to 1, so I could just put a 1 in the denominator. Y minus 2 quantity squared equal to 1, and that would be my final answer. Let's look at our last example. Here I have y's first, then x's. I see my y's are positive, my x's are negative, so the y's should come first, the x's should come second. So I notice right away that I have a 3 in front of my y squared, but I just want a 1y squared, so I'm going to factor it out right away. So if I look at the y's, if I factor out a 3 from a negative 12, I get a negative 4y plus blank. And then from the x, a lot of students forget that there's a negative 1 in front. I can't have a negative 1. I need to have a positive 1. So I have to factor out a negative 1, which leaves me with a positive x squared. And if I look at here, if I take out factor out a negative 1, I'm left with a positive 4x plus blank equals, and again I want to move this negative 1 over to the other side, which makes it a positive 1. Then I'm going to add my two blanks. I'm going to drop down the 3. Half of negative 4 is negative 2. I'm going to square it. When I square that, I get 4 minus 1. X plus half of 4 is 2. Quantity squared. When I square that, I get 4. But again, we want to be careful. 3 times 4 is 12, so I'm going to add 12 to the other side. Negative 1 times 4 is negative 4. So if I add this, again I get 13 minus 4, which is 9. But it has to be equal to 1 to be in standard form. So I'm going to divide each term by 9. So when I reduce, I'm left with y minus 2 quantity squared divided by 3 minus x plus 2 quantity squared divided by 9 equal to 1. I hope you feel a little bit better about writing equations of hyperbolas, whether you're given specific information about the hyperbola or given the general form.